The atomic theory is the idea that all matter is made up of fundamental particles, and the word fundamental is just a big word for small particles. So most of you know that the table that you're sitting at and the chair that you're sitting on are made up of little tiny particles, even though we can't see them. And you don't have to actually draw the picture, but hopefully that you're familiar with the idea that some particles make up the atom, and today we're going to talk about some of those particles and how they're arranged in the atom. Originally, scientists knew that matter was made up of small particles, but the difference between what they thought and what we think of today is that they didn't think that you could break down the atom any smaller. So they called it an atom, which actually means indivisible, but today we know that you can actually break it down into small particles. So this is just a picture, it's just a sphere, and again, they didn't think you could break it down any further. Today, we know that the atom is made up of smaller particles, and the fancy word for those smaller particles is subatomic particles. It sounds really fancy and scary, but if you just break down the words, it's easy. Sub just means under or less than, and atomic means atom. So what you're talking about is something that's smaller than an atom. Rutherford was one of the first people to talk about the parts of an atom, and what he did is he set up an experiment, and this picture kind of shows what he did. He took a piece of gold foil and he flattened it as small as he possibly could, so it was almost one atom thick. And he took an alpha gun. Alpha particles are just particles we'll talk about in the future, but they're just little helium atoms. And he shot the helium atoms at the gold foil. And what he expected is that all of the particles would go straight through the foil, as you can see in the detector, that they would hit the other side of the detector and go straight through it. What he was surprised at is that sometimes some of those particles bounced back toward him, and you can see two of the particles in the picture bounced back in his direction. And for us, it's not that big of a deal, but for the world of science, it was a huge deal. And the analogy is that if you held up a piece of tissue paper and shot a gun, and the bullets came back towards you, that's how weird it would be for the scientist. So what they did is they started to study the atom itself to see what could be causing some of those particles to bounce back. And if you can look at the picture farther down below, you can see that when it bounces back, it's because it hits the nucleus of the atom. And so Rutherford is famous for discovering the nucleus, which is the center of the atom. And this is just a little animation. So there's the alpha gun, and there's the gold foil. And the circular detector shows where the particles hit. So see how most of them are going straight through the foil? And that one, if you saw it, bounced back towards them. So again, most of them go straight through, and boom, that one went back towards them. So that's just kind of a visual to help you understand what he did. The reason this is so significant is that not only did he discover the nucleus, but he realized that because almost all of the particles went straight through the atom, most of the atom is made up of empty space. And one analogy that I've heard before is that if you picture a football field, and then you picture a green pea, like peas and carrots, if you put a pea in the center of that football field, the entire football field would represent the size of the atom, and the pea represents the nucleus. So you can see that most of the atom is in fact empty space, and there's just a tiny little dense nucleus in the center of the atom. And the crazy part is that all of the mass of the entire atom is really only in that little tiny nucleus. So that little green pea in the center of the football field is where all of the mass of the atom is. The reason for that is because electrons weigh pretty much nothing. And that's something I'm going to say over and over again until I can get it stuck into your head, because it's important that you realize that electrons do not contribute to the mass of the atom. So here's what you need to remember about Rutherford's experiment. When he shot those alpha particles at the gold foil, the first conclusion he made is that atoms are mostly empty space. And the reason he could figure that out is because most of the particles went straight through the foil. A few of the particles bounced back, and then that led to a second conclusion that there is a small, dense, positively charged nucleus. So let's define nucleus. The nucleus of the atom is just a small dense core that contains protons and neutrons. and the electrons are going to surround the nucleus. So let's just do a review of all the subatomic particles. I'm sure you've heard of these before in 8th grade, or possibly physical science. The first one is a proton, and the symbol for that is P+, neutron is N0, and electron is E with a little negative sign. The charges for these is that a proton is positively charged, just remember the two P's. Neutron sounds like the word neutral, so it has no charge at all. And then electrons have a negative charge. And electrons probably the one most people forget, so try to remember that electrons are negative. Relative to each other, so this is just relative mass, it's not an actual mass, which is why there's no unit. But compared to each other, protons and neutrons are about the same. Electrons, like we said, are so tiny that we consider them to weigh nothing. They actually weigh 1/2000 compared to the other two if they were both 1, but it's so close to 0 that we just consider it to be nothing. So the proton and neutron are located in the center, which we call the nucleus, and then the electrons float around the outside of that. And again, notice that only the neutrons and protons contribute to the mass. So here are the parts of an atom, and I want you to pause the video for a minute and go ahead and sketch this picture so that you have it in your notes, because visual representations will help you remember a whole lot more than just the words. So notice that the positive protons are in the middle, the neutrons are in the middle, and they have no charge, and then the electrons are surrounding the outside of it. And the nucleus is pretty important, so it's make sure that you understand it's at the center of the atom. It takes up all the mass of the atom. It contains protons and neutrons, that's the positive and the neutral ones, and the electrons surround it. And the last thing for today is just the chemistry joke of the day. So hopefully after this lesson you understand why it is funny. Alright, thanks a lot.